All right, in this video, we're going to look at constructing what are called corresponding graphs. That means that somebody gives us one graph. So we're going to assume that the velocity time graph is given to us, and we have to figure out what the position time graph looks like and what the acceleration time graph looks like. So you can see in the example that I have in front of me, it's actually already done. But I want to go through and explain to you how we get these graphs. So the first thing that I do is if I'm given the velocity time graph, I look at the graphs and I see they all go to 10 seconds. So I made myself a data table that went from 0 to 10. And I did a position or a distance, velocity, and an acceleration graph. So the velocity graph is given to me. So obviously I'm not going to write anything there. And I'm trying to figure out first the acceleration graph. And the reason I grade that out is I find that using the data table is not as helpful to me. I like to instead look at the velocity and graph out the acceleration as I interpret it. So what I mean by that is I'll talk to myself here that this graph says from 0 to 2, an object is moving at a constant velocity of -2. Well, if it's going at a constant velocity of -2, it means it's not accelerating. So from 0 to 2, it's not accelerating. So when something is not accelerating, it doesn't really tell you what it's doing. You and I now know it's going at a constant velocity of -2, but I'm going to point to that. All right, during this next segment here, the object it's going from -2 to -1 to 0, which means it is decelerating. And because it's happening below the x-axis, it's traveling in the negative x direction. So I have a negative and a negative, which means when I report my acceleration, I'm going to report it as a positive answer. And you could have guessed it was positive because this slope is going up. So the acceleration here is going to be rise over run. So that would be 2 over 2, and it's positive. So a positive 1. So I'm going to have this line here. All right, then next over here from 4 to 6, the velocity is 0. Well, if the velocity is 0, it's definitely not accelerating. So I'm going to put that here. And this actually stood for a velocity of 0. So this is one problem with acceleration time graphs. When you see the acceleration is 0, you don't really know what it's doing. In this one case, it was at rest, and the other one, it actually was moving at a constant velocity. All right, the next segment, it is accelerating again. And so this looks like it's accelerating in the plus x direction. And so the acceleration is going to be rise over run. That's going to be 4 over 2. That's a positive 2. So I'll draw a horizontal line there. And then at the end of the story, it is moving with a constant velocity of 4. If it's moving at a constant velocity, it's not accelerating. So I'll draw a line there. And this actually meant constant velocity of 4. So some people draw their acceleration time graphs just with a series of horizontal lines. And you can draw them that way, or some people like to go back and connect them with usually dotted lines. That's what I'm doing here, dotted lines, to kind of show how they all go together. But getting the acceleration time graph is not that difficult. So I find getting the position graph a little bit trickier. So let's talk through that one. So to find the distance traveled, it's going to equal the area under the curve of the velocity time graph. But the area under the curve doesn't give me the answer. It gives me the position at that moment, or how much distance I traveled during that time. So I'm going to start with 0, 0. And this is a graph that I do find using a data table helps me. So 0, 0, so I can plot that. All right, then at 2 seconds, I covered this distance, this area. So 2 times 2, that's going to be 4. But you can see that I covered this in the negative x direction. So I am at then a position of -4. So you can see at 2 seconds, I was at -4. And then I'll find the area here from 2 to 4. That's going to be 1/2 base times height. That's a 2. So I went 2 more units in the negative x direction. So 2 more units in the negative x is going to take me to negative 6. So you can see that up at 4 seconds, I was at negative 6. And then the velocity was 0, which means I wasn't moving. So I was at rest. So I didn't change my position. So at 6 seconds, I'm still at negative 6. Then from 6 to 8, I started accelerating, but this time I'm accelerating in the positive x direction. And so I need to find the area of this triangle, 1/2 base times height, and that's 4. So I went 4 units in the positive x direction. So I was at negative 6. I'm going to go 4 units in the positive direction. That would put me at negative 2. So at 8, you can see that I'm at negative 2. And then the area of the last shape is 8. So I'm going 8 more units in the positive x direction. So I'm at negative 2. I go 8 more positive units, and that would take me to a positive 6. So at the end of the story, I'm up here at a positive 6. So once I get my key points, then I can kind of draw a smooth line through the points to show what the position time graph will look like. In summary, my velocity time graphs are usually pretty rectangle-y and triangle-y, and my acceleration time graphs are usually a series of horizontal lines, and my position time graphs is where a lot of the curves come in. So that's kind of a clue of what they should look like if you do everything correct. Okay, I hope this video was helpful.